everybody. How's it going? Good? All right, let's get started. So it's funny because when I first wrote this main slide, it actually said unleasing. And I'm like, oh. Okay, so I want to talk about XR, the impact that XR has on digital twins, on communication, on lots of different forms of the way you can interpret data. And so I really think that there's a place for intelligent XR. So where you are getting information through an immersive environment that is from other people's experience, and that's where the intelligence comes in, and I'll explain more of that later. But I think we're at this really interesting inflection point in our industry, and it's really wonderful to see, because we have all of these technologies that are coming to the forefront, and they're allowing us to embed insight into product creation and manufacturing and the way we work. And so I love this image. It's the first ever photograph of light as both a particle and a wave. And I think it kind of represents what we can do with immersive technologies and with all of these other enabling technologies, AI and so forth, because they can represent multiple modalities, and lots of different insight can come out of that. All right, so this is an eye chart, and it's, you don't need to read the whole thing, but the real value here is that we're looking at the way it's culture, process, people, and tools. And in each one of those areas, there is so much knowledge. And there is knowledge of tools, there's knowledge of how people work, and there are some cultural norms that go along with that. And understanding how all of those things work together is really important. But the other important part is being personally connected to data allows a lot of these things to be revealed in context to you based on your experience and how you think about things. And so I was introduced as Emergenary Enterprises, which is true. And also true is my work at Ford Motor Company. So I spent 30 years at Ford Motor Company. Oh, thank you, yay. And my whole career at Ford, I never worked on a vehicle. I always worked on enabling technologies. I was always in computer graphics. My degree is actually in computer graphics programming, and I used to write CAD code. So Ford had their own CAD tool, and I wrote CAD code, and I was like, really happy writing code, stacking up Mountain Dew cans, staying up all night and doing the whole thing. I loved it. But Ford wisely decided not to do that. And so I moved on and started getting into other forms of computer graphics, which led me to become Ford's first global specialist in virtual reality, and then later on the immersive reality specialist. And so I learned a lot about vehicles, and that was, of course, very important. But what this is really showing is, if you just kind of follow it from the roof and you kind of go clockwise around, like a vehicle is made of parts have assemblies, sub-assemblies, they have functions, there's all these things that need to be measured, understood, and then propagated. The information needs to be propagated. So it's definitely a multi-dimensional problem to try to incorporate XR in these environments, because the amount of information and the variance of the information. Part of this doesn't even attack the artistry, like the absolutely beautiful design of a vehicle and ergo and all of that. This is just like one little piece of it. And so the way it kind of works is that there is a collaboration between all of these different disciplines. And people like to silo. They like to have, they know their discipline. They like to focus on that, focus on this, focus on the other thing. But the power of XR and an intelligent digital twin is it allows you to go broad and deep. And it allows you to relate to somebody whose view you might not understand otherwise, because you can receive their view personally connected through XR in a manner that works for you, so you can understand their perspective. And so, okay, I'm gonna go back. Just please note the little colors and the little bars, because I'm gonna take you through a series of before and after examples that kind of represent the way things are and the way they either are now or can be. And so automotive is notorious for clay. Clay is still a very valuable mode of development. There are a lot of good technologies that can do touch feedback, but not to the level of human touch. So clay is still used in automotive, and it will be for some time coming. But it is possible to use XR and receive more input. So instead of looking at clay, which you saw the other example that was just for design, now there are ways of getting immersed, telling stories, doing user experience. The picture of the F-150 at a camp scene was like that fire actually crackles, and you can take your camping gear and load it and see how it fits in your bed and what you can do. And so there's the one in the middle that looks like beige color. That's like a 3D drawing, so you can like kind of draw around you and understand like volumetrically where things are. So there's just much more information that you can get from design. You can get ergo, quality, like all of these different things that you couldn't get just from like looking at a clay and judging proportion and design. And so for UX, I think this is a really interesting one, because these are both virtual images, and they're both technologies, headset and cave, are extremely valuable tools for immersive, but they're not necessarily good for when you do need to touch things. And so and that reminds me, every technology has a strength, and play the strengths and minimize the weaknesses. So this is an example of this is a chopped up Mustang and 3D printed parts with microcontrollers that can be put in different locations, and then now the part changes based on where it gets located in the immersive environment. The steering wheel can be instrumented, and you can touch and do all kinds of your personal connection to the vehicle, but then you're looking at a beautiful vehicle instead of this chopped up thing with only one seat. So that's a very powerful tool. This is one of my favorites, because this was there. If you look up at by the lights, there's actually a windshield there, and somebody would crawl up there, sit in that car seat, and look at glare. Seriously. And so instead of that, you can do real-time ray tracing in an immersive environment, and then check out the way light propagates in the scene, and how you can actually see the cluster in the side glass in this from the ray tracing. But this is in a VR environment, and the ray tracing is real time, so it responds to your movements. You change time of day, you can measure, you can do, understand perspectives, different eye points. So this is perceived quality. So these are still being built, and this is basically scanning a part and then seeing if all the locators are in the right spot. But instead of that, you can create the sections, and instead of scanning, you can use math data, which we don't talk about enough for XR, is actually using not tessellated data, but NURBS data, that surfaces that are based on math, and being able to cut through those sections and see what things look like, why, if they're meeting proper tolerance and all of those good things. And then for engineering, CAD is king, especially in automotive, and there are many reviews that are done that have parts that look like this. But this is an entire vehicle with everything, and this can be done in an immersive environment in with real-time ray tracing. Like, you can do that now. That the technology exists to make beautiful vehicles like this that are in real time, that have ray tracing, that have an engine and a transmission and the whole powertrain, and have engineering integrity and look amazing. And then you can see how many different functions at the bottom work along with that, because that is really opens up the entire, well, not the entire, but very many disciplines in those verticals to understanding the power of where it is in product development, and then how XR can help with understanding, because looking at this on a flat screen is nothing like getting immersed in it. And you do understand much more about the proportion when you're, walking around the vehicle and, kind of looking down and over, getting in, seeing the glare, all of those things. And so this is just a live, like, MRI kind of sectioning kind of capability. And this is just another engineering application. And you can see, this really goes along with the other slide. It's just so many things that you can do where engineering is represented in the context of the design. And then in manufacturing, there are so many use cases. And evaluations are still being done like this. This is a recent thing I just looked like 2 weeks ago to make sure this is still being done. There's still a company that does these things. And this is basically simulating a line and then understanding the line after the fact, and then measuring and scanning and making sure that you're meeting tolerance. But you can do this. So some of these studies, you can use a prop and then use the tools that they do to, like, put the transmission in the vehicle and, create that environment and then do that simulation. And in this case, the person is mocapped up, and then their body is being, in their posture while they're doing that, is being scanned and then saved and then applied to a digital human to understand if the body can do that repetitive motion without injury over a long period of time, and what extents of the population can do that based on that digital human. And so this is another manufacturing process, and so process variation really comes in. That thing on the that your left is actually a vehicle where they move little dials, and then the parts like move apart, and then they measure it. And that thing is like super expensive. It's like insane. And then the other one, those plates move, and then they look at the variation between the components. But this is a patent that I have with a few other friends at Ford. And if you notice, this is the entire manufacturing process applied to the design and before any line is built, and then considering all kinds of like sigma of variation, and then morphing the geometry and then showing it to us. So these are a select set of like worst cases so that you can kind of see it in the video, but you see like how it's crumpling and like warping and moving. Those are because the locators after a period of time cannot bolt properly, like the fender can't, or the bumper can't bolt properly, and so it twists and moves, and so those conditions can be represented, and literally, and one of the things that's very important is that bringing that data in means that you have respected the hierarchy and the way that product is defined in the organization. This can't happen unless the product hierarchy is maintained. So somebody could come in to one of these immersive reviews 5 minutes ahead of the meeting and say, here's my manufacturing process, and we can dump it on, in the environment, and then this interface comes up, and they can see all of their data, and they can pick which conditions that they want, and just look at things. And that's the secret sauce, and that's the hard work that is not, I think, talked about enough, but extremely critical. Now, creating those surfaces does need some love. It just doesn't happen in 5 minutes before a meeting. But the actual tolerances and like checking out like AV gaps and like, gaps that, can result in some twist, those can all be seen without any pre-work if you maintain a relationship to the product structure for the way that you're designing and engineering your product. And so here's a simulation example. This is a computer-aided engineering study of a defrost pattern. And so looking at I'm from Michigan, so it's cold. And when you get in your vehicle and you have to wait for the windshield to defrost, what is the optimum pattern so that you wait less time and the more people can see out and can get going safely? So that's like the problem. So those are defrost patterns, and this is what the engineers would get these images, and they would have a slider, and they could kind of like watch the defrost pattern like on the slider. But this is, I think, a much better way. You get immersed in the environment, and you can represent the analytical with the rainbow of defrost, and you can also represent what the customer experiences by putting frost shaders on all of those rainbows, and then watching the defrost pattern happen, and then changing the viewpoint of the different people, and then seeing who can see what and when, at what time can they go safely. And that's XR enables that. It's not nearly as good on this flat screen as it is when you're inside that environment. And this is a perfect application for cave because you get like a really nice, like wide field of view, and you feel surrounded by it, and your whole goal is to look. But any kind of immersive environment is an advantage over like just looking at it on a flat screen or looking at it the way you saw before. And you can see how many different functions that opens things up for. And these are other simulation examples. The one on the upper right, I think, is really interesting. It might be really hard to see because it's really needs to be seen in ray tracing, and that's why I have this up. And because on the hood, there's a little divot, and the divot is very small, but it's a palm print study. So they actually do studies like if you lean on your hood with, how much force can it take and then still pop back and be okay? And when is it too much and it'll leave a dent? And so they actually call them palm print studies. And so usually measuring that deviation for that little bump is very hard to do, but it really becomes apparent with the right lighting conditions with immersive ray tracing. So you can kind of look around and, see. So it might not be that good, but that condition under nighttime with these weird lights seem to make it pop. Defrost and like heat, like that representing airflow, even though you can't feel it, just to, see it coming at you. Stone chips, like how will your, vehicle work under different conditions, and, like analyzing where the little stone chips might come out in an immersive environment is good. And the bottom one doesn't look like much, but it's actually crash. So it's like the vehicle like bam, slams into the wall, comes back, slams into the wall, comes back, and then apply the slicing through it, the MRI slicing capability. And what it gives the engineers, the crash engineers, is an understanding of how things are failing during the crash event. So they will generate movies and 360 movies, but that's not as much information as you can get in the immersive environment where you're able to watch like the rivets pop and like rotate and just kind of like, you get so much more information. And when somebody came to me and said that they wanted to do this, I'm like, yeah, okay. And that's another thing is like, I'm not an expert in all of those disciplines, but it really taught me to listen and respect the way they think and apply things that work for them and not things that I think they should have because I think they should work that way. And that's, I think, a critical mindset, or at least it was for me, for the way this, like the successful deployment of some of these technologies. And so smart cities is another thing for digital twins and XR, like having a view inside, like understanding vehicle-to-vehicle communications, like being in an environment and be able to do some storytelling, building worlds, and then having the world respond around you. Like there is so much to do in the immersive space with smart cities, digital twins, and then experiencing them either from like the overlord view or the personal connection, enjoying an experience. Okay, and then this is very important. There's so much that can be done. There's new manufacturing technologies that are coming out, and the industrial Internet of Things tied in with the intelligent digital twin experience through XR is like an amazing enabler that's just fantastic. And so I want to leave with this thought, which is we're not there yet. And this is just my like swag. I'm just like guessing at, I don't have like good data that these are all true, but it is true that we're not at 100% utilization of intelligent digital twins, and we're definitely not at 100% utilization of using XR in these spaces. And so the call to action for everybody is to like attack all of these things that we need to do in a way that chips away at the problems that we have. We've come so far. It's not consistent among different companies. It's also not consistent among different people, like their culture in the different companies. So like some areas adopt more than others because they're more amenable to XR compared to other areas. So this is a very, like it's a big problem. It's a problem when it's solved in increments. It's not like, okay, that is at 100% and we're all good for whatever that is. That's just not how that stuff is working. So I'm just saying this because we have a lot to go, and I think the other thing I wanted to say about this is that we, in XR especially, don't implement enough technology where we learn from what we've already done. And that's one of the things that I'm very interested in pursuing is how can we learn from an experience that somebody else has had, from an analysis that somebody else has done. Like that intelligence, the AI part, like training a model of a product is where we should get to. And I think when we do that, then I can be in an immersive environment and I can have the benefit of those that came before me and learn the things that they learned from my perspective. And that's where XR becomes so valuable, is it's my understanding, my perspective. It's very relatable to me, and I'm not trying to be like an egomaniac or like self-centered, but everybody has their own perspective, and when the technology relates to you, it is much more powerful and much more effective. And like having those prior learnings related to you is really, really valuable, and I think where we need to go in this industry. And so I like this picture. It's very staged, but I think it's kind of neat. And because extending your knowledge, your collective knowledge, through the technology is where we really need to get to. So like, that's what I was trying to get at with the, we're not at 100% utilization or anywhere near right now. But the ability to collaborate, the ability to share, the ability to have everybody personally relate, but to connect, is the value that XR gives. And it's not the same as Zoom, it's not the same as PowerPoint, it's not the same, like we all know what the value is, but it's like, how does it manifest? It manifests when people can share and understand each other, and then that's when success really is realized, in my opinion. And so I like this image because like, there are multiple people in this room, one person is immersed, but they're all sharing and they're all talking about the vehicle. They're not thinking about, you know, like the weird situation that they're in where some guy has this clunky thing on his head with markers, and they're actually just problem solving. And when that happens, I would actually go in and just kind of take some pictures. Like, this room would be, it's a room where a life-size virtual vehicle can be there, and then they can understand different perspectives. And I just think it's an interesting dynamic. And so what happens when all this works is you have this collaboration where everybody is sharing, and it becomes more of a web and less of a like silo. And so the value is that it propagates information amongst these cross-functional teams, and the value is a ripple effect throughout organizations. And so that's what I have. Thank you. I think I ran a little over. Thank you.